Hello, in this video, I will do a quiz on optimization word problem. So, oh, um, so it says find the point on the graph of the function closest to the given point. And I did not write the function or the point. So the function is y equals square root of x from the point 4, comma 0. Okay. So yeah, let me reread the problem. Find the points on the graph of the function closest to the given point. And we are given for the function y equals radical x, and the point is 4, comma 0. So what are we finding? Are we finding a min or max? So it says closest, so that means that is a short distance, the shortest distance, right? And that means we have a min. So we are technically looking for a min. So step one, first draw the best image you can think of. So I know how y equals square root of x is. It looks like this, or roughly looks like this. So it's a square root graph, so it does equal to 0. So it kind of curves and it slowly starts to increase, right? So here's the function y equals radical x. And then if you plot the point 4, comma 0, 1, 2, 3, 4, here's 4, comma 0. We got to find a distance that's the shortest. So it could be this distance, it could be this distance, or it could be this distance. It's got to be the shortest distance. So what do we know? We know that, how do you find the distance? To find the distance, you can use the equation what distance equals square root of x squared minus 1 square plus y2 minus y1 squared. So do we even have 2 points? Yes, we do have points. What are our 2 points? One of my point is x comma y, because I don't know. Yeah, I don't know one of the point, so I'll call it x comma y. And my other given point was 4, comma 0. Okay, so what I'm going to do is I'm going to label the first point x1, y1, and the other one x2, y2, right? And I'm just going to put it in the formula. So d equals square root. So my x2 is 4, minus my x1 is just x square, plus my y2 is 0, minus my y1 was just y square. Let's see if I kind of clean this up. Let's clean this up. What's 4 minus x squared? Well, you could do the long way, like split it out 1 by 1. I don't want to do that. I'm going to do the shortcut. The shortcut is, it comes from this rule, a minus b squared equals a squared minus 2ab plus b squared, right? That's the rule I want to do. So we just got to figure out our a and our b. So my a is 4 and my b is x. So a squared is 16 minus 2 times a, which is 4. My b is x, and then my b squared is x squared. Put it all together, you get negative 2 times 4 times 8, that's negative 8x plus x squared. So 4 minus x squared is 16 minus 8x plus x squared. And then 0 minus y parentheses square, that's really saying negative y square, which is just technically just positive y squared. Okay. So this is the simplified version. So I drew my image. I kind of yeah, I drew my image and now I got to find my two equations. So did you know they were given you one equation, which is y equals square root of x. And then the second equation is your distance equation. So my distance is 16 minus 8x. Is there anything I can combine or fix? Not yet. Okay. Now what I'm going to do is, what can I do? So I have my first, my two equation. So the next step is substitute. So I already am given my y value, so I'm going to substitute that back into the distance formula. So it's going to be d equals 16 minus 8x plus x squared plus, what is y squared? So we know that y is radical x. Y squared is just you square the radical. So that would be just x. Okay, now is there anything you can do? Wait, did I make a mistake? Okay, now we can combine like terms. What can you combine? I can combine the negative 8x and this positive 1x, which is negative 7x. Plus x squared. And then what can I do next? Now I'm going to take the derivative of the distance equation, right, and set it to 0, and then find my critical value. What I could do is I could use the chain rule. I could do that, right? Set dx, set this to 0, find the derivative in respect to x. Or I can get rid of the radical first. That's what I'm going to do. I'm going to get rid of the radical first by squaring both sides. So d squared is d squared. Over here, when you square a radical, the radical disappears, so it's just 16 minus 7x plus x squared. Okay, then I guess I could take the derivative in respect to x. So let's look at the left side. What is d squared? What's the derivative of that in respect to x? It would be 2d over 2d times dd over dx. And then over here, just take the derivative in respect to x. So this one is 0. The derivative of negative 7x is negative 7. The derivative of x squared is 2x. Okay. What to do next is I want to get dd over dx by itself, so I have to get rid of this 2d by, I guess you could divide both sides by 2d. So let's cancel, so you're left with dd over dx equals to negative 7 plus 2x over 2d. Okay, then what I would do is set your prime, your dd over dx to 0. 0 or 0 over 1 equals negative 7 plus 2x over 2d. And if I cross multiply, the 2d becomes 0, right? 0 times 2d is 0. 1 times negative 7 plus 2x is negative 7 plus 2x. Solve for x, so I'm going to add 7. Add 7, I get 7 equals to 2x. Divide this by 2, and I get x equals 7 over 2. Okay, now that is your critical value. We got to verify that we got to verify that x equals 7/2 is an actual minimum, right? We want to find the least, what do we want to find? We want to find the closest. So yeah, we got to find minimum. We got to verify this is an actual minimum. So what you could do is use your test point method, put 7/2 right in the middle, and then test a region left of 7/2 and a region right of 7/2. So, and you could test, you're going to put it in your dd over dx function. So if I plug in, so 7/2 is about like 3.5. So I need a number less than 3.5. So maybe I'll just use 0. That's -7 plus 2 times 0 over 2D. 2D is really irrelevant. You don't need to worry about the 2D. So this is just going to be 0 plus -7, which is -7. So it's just a minus. And then a region left, I mean, right of 7/2, maybe I could do 10. I don't, yeah, 2Ds are like, is like a constant, so you don't have to worry about that. 2D, I mean, so this would be 13, which is positive. So according to your sign chart, a minus to a positive is a local min. So this verifies that x equals 7/2 will give you a minimum value. Okay, but that's not the answer. What were they saying? They were saying find a point. So we need a coordinate, right? And what did we just solve for? We solved for x, which is 7/2, right? We need an equivalent. So our x coordinate is 7/2. That's fine. How do you find the y coordinate? So the y coordinate, remember we said that y equals radical x. So it's going to be y equals square root of 7/2. And this y, I don't like it like this, so I can simplify it. This could be simplified as square root of 7 over square root of 2. And then you can rationalize the denominator by multiplying top and bottom by radical 2. So this would be radical 14 over 2. Okay, so this is the point that's closest. This is your min. And that's it. So this is the answer. So this point here will be the closest to this graph. Okay, I will stop here. Thank you.